Alright guys, so right now I'm going to work through the problems, the extra practice set of problems that is going to be similar to your test, so this will be beneficial. The extra practice is listed right here. Alright, so first we're going to do a RRAM on f of x equals 2x minus 5 on 0 to 5. So let's go ahead and get started on that. So f of x is equal to negative 2x plus 5. Let me double check that, make sure it's right. Alright, nope, it's backwards. 2x minus 5. Okay, let me just correct that. 2x minus 5. RRAM 0 to 5. 5 subintervals. Before I get started, let me make sure you're aware of what you need to do on your test. Number one, you need to do a correct graph. Okay? So I'll just Roman numeral this stuff. Number one, you need to do a correct graph. And I only need the interval 0 to 5. So I'm going to go 1, 2, 3, 4. I'm going to make sure all my units are correctly displayed on the graph. So I'm just using my slope. Alright. Here's my function. Alright, I'm going to correctly label my x-axis. Okay, make sure we do that. And now I'm going to, so that's the first thing. The second thing is the bars. Alright, that's what we got to do that. So we got an RRAM going, so we got to know it's the right endpoint from 0 to 5 with 5 subintervals. It's a good thing to go ahead and calculate your delta x first. It's b minus a over n. Sorry, that's sloppy. 5 minus 0 over 5. Delta x is equal to 1, so our base of each rectangle is 1, so we know that each base is 1. It's not like it's a 2/3 base, so I can pretty much go ahead and draw these rectangles knowing that they're going to be 1 unit wide. Alright, so there we go. We can go ahead and shade in so there's no Alright, so there you go. Alright, so cool. Alright, let's go ahead and move on. So that's the second thing is your bars. Your bars or your trapezoids have to be done correctly. Alright, third thing that you have to be able to do correctly is, let me look at the rubric for you. Test here. Here's your take-home test right here. And alright, so you've got to be able to correctly find and circle delta x, x of IR, x of IL, x of IM, whichever one you have to find, the function, whichever applies, then write your summation formula with your delta x and your new f of x. Then you may simply add your terms. Alright, and then a couple of them I asked you whether it's an upper sum or a lower sum. Alright, on this problem it would be kind of difficult, but if you just take these two triangles and here's a little one. Alright, so that's the empty space, these triangles right here and a smaller one. You've got two of these triangles right here that are more than what you need, plus much more than what you need right there. So you have much more than what you have. This piece, this extra piece, is more than this. Not this lack of area. So this area right here is more than this lack of area, and these two kind of cancel out these two. So you're just looking at those two, and obviously it's more area than we need. So this would be an upper sum. Okay. All right. So, but this one's kind of difficult to see. I think on the ones on your test it might be easier to see. So let's go ahead and start. We got our delta x. Alright, so this is the third thing we're gonna do. We're gonna find delta x, x of I r, and f of x of I r. That's the third thing we gotta do right here. Okay. Alright, so delta x. Now we find x of I r, and that's equal to a plus delta xi. This problem's easy because a is 0, delta x is 1, and so x of I r is equal to I. So basically I'm swapping the x with I. So f of x of I r, I simply replace the x right here with I. So 2i minus 5. Alright, so this was important, circle it. This is important, circle it. Remember, every step is important, so you gotta circle this stuff. Alright? And now we have our summation. I equals 1 to, how many things are we adding up? 5. Delta x and f of x of I r. You're not done here. Now we gotta substitute them in. Alright, so summation from 1 to 5. Delta x is 1. That's easy. F of x of I r is 2i minus 5. I'm going to simplify this before I get started. No need for that 1. And now I'm just going to show that I'm plugging in 1, 2, 3, 4, and 5. So 2 times 1. At this point, it really you really could just plug in your answers. 2 times 1 minus 5 is negative 3. Alright, 2 times 2 minus 5 is negative 1, and then 1, and then 2, and then 3. I think, yeah. Let me double check that. 1, no, 1, sorry. This is when I plug in 4. When I plug in 4, I get 8 minus 5 is 3. When I plug in 5, I get 10 minus 5 is 10, or 5. So what does this all add up to? Let's see. These two cancel. So I'm left with 5. Okay, I'm left with 5. So 5 units squared is my answer. Make sure you circle that too as well. Alright, so here, these are the things that, all the things that need to be circled, okay? Delta x, x of I r, f of x of I r, your summation formula, and your answer. Also, the graph has to be good, and your bars have to be good, okay? Alright, let's move on to the next example. Just to let y'all take a quick look-see at that one more time before we move on. Alright, next example. And my battery is dying. Hold on 1 second. Hayden, you okay? Alright, and we're back. So, next problem. Let's go to the extra practice. Now we've got f of x is equal to negative 1/2 x squared plus 8. Okay? It's an LRAM. Alright, so I'm going to go ahead and start copying. I'm going to use a separate sheet of paper for every problem. Not that you have to, but you should. Alright, so f of x is equal to negative 1/2 x squared plus 8 LRAM. We're going to go use negative 4 to 4 and 4 subintervals. Okay, so here we go. Alright, so first we start with the graph. Now our interval is negative 4 to 4, so our x-axis should be negative 4 to 4. Okay. Many people struggle with writing too much on their graph. You only need to know what the graph looks like from negative 4 to 4. And if you have your graphing calculator, this should be easy. Okay. Plus 8, 1, 2, 3, 4, 5, 6. You can make it a little bit higher. 7, 8. Alright. Boom. Negative 4 to 4. Okay? And if you go to your graphing calculator, your calculator will be able to, I don't have mine on hand, but you can set your calculator, your x. You can go to I think it's dimensions or graphing properties, and you can set your x min to negative 4, x max to 4, positive 4, and your y max to 8, because you know the y-intercept's 8 based on the function. Okay, and that'll just, but either way, however you do it, you can just put it in your calculator and look at the numbers. Alright, so here's the graph. Check, got the graph. Now I want 4 subintervals, so let's go ahead and find delta x. Delta x is equal to b minus a over n. Delta x is equal to 4 minus negative 4 over 4. Delta x is equal to 8 over 4. Delta x is equal to 2. And it's kind of easy. If you're going to fit 4 rectangles in here, you're going to have them spaced out two at a time, 2 units at a time. So we're going to do an LRAM. So this little bitty rectangle won't go nowhere. This little bitty rectangle will. Alright. This little bitty rectangle right here. This one right here. Alright. Okay, so there we go. That's all we got. Okay. And so you got these 4 rectangles. One of them doesn't go anywhere because the left endpoint's at 0. Alright, so let's go ahead and calculate it. We got our graph, we got our bars, now we got our delta x, now we need our x of I, L. That's a plus delta x, I minus 1. X of I, L is equal to negative 4 plus 2, I minus 1. X of I, L is equal to negative 4 plus 2i minus 2. Therefore, x of IL is equal to negative 6 plus 2i. Alright, so there you go. That's the next thing we need. Now, of course, we're progressing to f of x of IL. F of x of IL. We've got to plug in x of IL into x right here. So that's a negative 1/2. Negative 6 plus 2i squared plus 8. Now for our purposes, we're not going to FOIL that out. I know I did on the notes example, and that made that example extremely horrendous and hard to do. So we are not going to do that. I know that should make you happy. Alright, so now that we have that, we're ready to progress on to the formula. Summation from 1 to 4, we're adding 4 rectangles. Delta x is 2. F of x by L is negative 1/2. Negative 6 plus 2i squared plus 8. I'm going to do us all a favor. Okay, I'm going to factor that 2 out. Okay. Notice I don't have a calculator here, so if you don't have a calculator, this is what you're going to have to do. I'm going to factor that 2 out. Now I'm going to plug 1, 2, 3, and 4 in for this stuff. So you have negative 1/2, negative 6 plus 2 times 1 squared. And I guess I could just write that as, let's just go ahead and write that. That would be negative 4. Alright. Plus 8. And there you go. That's 1. That's plug in 1. You get that. Now plug in 2 plus negative 1/2. Plug in 2. Negative 6 plus 2 times 2 is negative 6 plus 4 is negative 2 squared plus 8. Alright. Now I have to do the next one. So plus negative 1/2. Now 3. 3 times 2 is 6. Negative 6 is 0 squared plus 8 plus negative 1/2. Plug in 4. 2 times 4 is 8. Negative 6 is 2 squared plus 8. And there we have it. Now I could just plug all that into my calculator, but I don't have a calculator, so I'm going to be algebraically savvy here. I'm going to take these 4/8 and I'm just going to rewrite them as 8 times 4. Alright, and so now I'm left with adding a bunch of negative 1/2 times negative 4 squared plus negative 1/2 times negative 2 squared plus negative 1/2 times 0 squared plus negative 1/2 times 2 squared. And that is what I'm left with. See right there? Alright, so I rewrote everything. I think I'm going to make it even easier on me because they all have negative 1/2 in common. So I'm going to take that out. So it's going to be 2 times 8 times 4 plus a negative 1/2 times 4 squared, negative 4 squared plus negative 2 squared plus 0 squared plus 2 squared. And look at that. That's so much easier. This is so much easier than this. But if you have a calculator, this is no problem. But I'm dealing with no calculator here, which is a situation you might find yourself in on the AP exam. Alright, so 2 times 20, 32 plus negative 1/2 times 16 plus 4 plus 0 plus 4. 16 plus 4 is 20, plus 4 is 24, divided by 2, negative, is negative 12. 32 minus 12 is 20, times 2 is 40 units squared. Alright, so that's it for number 2. Okay, so you see why each of these should be written on a separate sheet of paper, hopefully. Some of y'all that write small and sloppy, please just be neat, okay? And then nobody writes sloppy, just sometimes we don't show steps. So make sure that you circle your answers appropriately. Alright, we're going to move on. Let me let you take one last look at all that. There's the top. There's the bottom. There we go. Alright, so next on our extra practice, which is just like the test, is f of x is equal to I have my paper ready. Alright, f of x is equal to cosine 2x. We're doing a TRAM. We're on pi to 2 pi with 4 subintervals. Okay? Alright, so here we go. Alright, so first we need to do our graph, and we all know that cosine's graph starts at 0. Alright, but this is cosine 2x, so it's different. So use your calculator here if you don't know what this means. But essentially, you can easily find all the x-intercepts. Alright, you can easily find all the x-intercepts by taking cosine 2x. So x-intercepts. Taking cosine 2x, or sorry, f of x equals cosine 2x, and f of x is y, so I'm going to set cosine 2x equal to 0. Now I don't have to think about where 2x is equal to 0. I think about where cosine is equal to 0. So where's the cosine equal to 0? Cosine is equal to 0 when x is 0, which is at pi over 2. Alright, so cosine of 2x is equal to 0 at, and it's not x equals pi over 2 though. It's not x equals pi over 2. Alright, what is the next one? 3 pi over 2. And 5 pi over 2. Alright, it's not just that. So it's not just, and this can be written as a sequence. It would be pi over 2 plus pi n. Right? It's not just that. Okay? It's not just x equals that. It's 2x equals that. Right? So really this would become, alright, I divide everything by 2, right? I divide everything by 2, and then, which is the same as multiplying times a half, so it'd be pi over 4, and then 3 pi over 4, and then 5 pi over 4, and then so on and so forth. Okay? Now you have to think about this. Well, you really could just go back here and say, alright, so what is the formula here? And you don't have to do this. You can use your calculator. But if you don't have a calculator, guess what? This is what you have to do. Alright, it ends up being divide both sides by 2, which is the same thing as times a half. And that's divided by 2, so that's pi over 4 plus pi over 2, which is 2 pi over 4. And so yeah, now so that's the x-intercepts. Alright, so here we can just start with, pi over 4, and then we have pi over 2, then 3 pi over 4, and then pi. And so we got to extend this because we need more room, right? And then so that's 5 pi over 4, and then 3 pi over 2, and then so that's 6 pi over 4, 7 pi over 4, and then 2 pi. Okay? So all the x-intercepts are now here. And it's easy to see where to continue from there. Excuse me. Alright, 7 pi over 4. And we all know cosine starts at 1. Alright, cosine of 0, even 2 times 0 is 1. And then it oscillates to -1. So here is what your graph looks like. I know that's not to scale because I just shouldn't have went lower right there, but I apologize. Alright, so we're looking at a TRAM with 4 subintervals, alright, from pi to 2 pi. Okay, so let's go ahead and get started. Pi, the trapezoid from pi to 3 pi over 5 pi over 4 is actually not going to be a trapezoid. It's going to be a rectangle because the right endpoint won't go up at all. Alright, see that? The right endpoint doesn't go up at all. Let me make sure I want to do a TRAM. Yeah, I did. I want to do a TRAM there. Okay, so then you have, what you have is you don't have actually a TRAM situation. You really have triangles. All right, and this would be, you know, pi comma 1 and then 5 pi over 4 comma 0. So you don't really have a true trapezoidal situation. But even though this looks funky, even though it might not, like, you got to have the graph check and you got to have your trapezoids, which are really rectangles in this case, double check. If you work through the steps, you'll be fine. So let's find our delta x. Alright, delta x is equal to b minus a over n, which is equal to 2 pi minus pi over 4, which is equal to pi over 4. So each base is adding pi over 4 each time. Okay? And we've already seen that. We already know that. So we have our delta x. Alright, now we gotta find our, not our f of x of I. Well, and for TRAM, let's remember the TRAM formula. Okay? TRAM takes a little bit of remembering. 1 to 4 delta x, f of x of I L plus f of x of IR times, times delta x is the height, and oh, we got 1/2. Sorry, see, even I forget. Alright, how do I remember that? Because I know the trapezoid formula is 1/2 base 1 plus base 2 times the height. If you remember that, you'll be fine. Okay, so there's your formula. So you know you got to find delta x to check. We got to find x of IL. So that's a plus delta x I minus 1. And so now we're just plugging and chugging, y'all. This is very simple. It's cut and dry, plug and chug. Alright, so what's A? A is pi plus delta x is pi over 4, I minus 1, x of IL equals pi plus pi over 4, I minus pi over 4. Alright, so what's pi minus pi over 4? Pi minus pi over 4, that's 3 pi over 4 plus pi over 4i. Okay? So there's my x of IL, circle that. Alright. Now, I'm going to find my x of IR. That's a plus delta xi. This one's easier. A is pi plus delta x, which is pi over 4 I. And I'm done with that. That can't be simplified anymore. Now I find f of x of IL, which is cosine of 2 times all that, 3 pi over 4 plus pi over 4 I. Well, let's simplify that. That's f of x of IL equals cosine. Now we're just working with fractions. 2 times 3 pi is 6 pi over 4 is 3 pi over 2, plus 2 times pi over 4 is pi over 2 pi, and there you go. This seems like a lot, guys, but it's basically crunching numbers, fractions at this point. So here f of x of IR is cosine 2 times all that, pi times plus pi over 4 I. Okay. Alright, so f of x of IR is going to equal cosine 2 pi plus pi over 2I. Okay? Alright, so we've got our f of x of IL, check, f of x of IR, check, 1/2, doesn't change. So now we're ready to do our summation. Our summation, I equals 1 to 4, we're adding 4 things, and it is 1/2 cosine 3 pi over 2 plus pi over 2 I. Okay, I don't know why I ended my parentheses right there, I'm sorry. Alright. Plus cosine 2 pi plus pi over 2 I in parentheses times delta x, which is pi over 4. Woo! That's a lot. Okay, but you know what? Once you get to this point, and I forgot, yep, circle, circle, circle. Once you get to this point, it's rather easy. You're just plugging in 1, 2, 3, and 4. But let me make it easier on you. I'm gonna make it easier. This and this, take it out. Okay? I'm going to take this out, I'm going to combine those and take them out. That's going to become pi over 8. Alright, now I plug in 1. And let's see what we get. Plug in 1 here, that's 1/2 plus 3 pi over 2. That's cosine of 4 pi over 2, which is 2 pi. And then plug in 1, that's pi over 2 plus 2 pi. That's cosine of 5 pi over 2. And the cosine of 5 pi over 2 is really the same thing as the cosine of pi over 2. Alright, so we got that one. Now we got to plug in 2. Alright, ready to plug in 2. So cosine of pi over 2 times 2 is 2 pi over 2. Plus 3 pi over 2 is 5 pi over 2. Alright, my pencil is kind of wearing out. So just bear with me, that's 5 pi over 2. Sorry. Alright, and plus cosine, plug in 2. That's 2 pi over 2. Alright, which is pi, plus 2 pi is 3 pi, cosine 3 pi. Alright, now plug in 3. Okay, so we have now cosine. Alright, plug in 3, you get 3 pi over 2. 3 pi over 2 plus 3 pi over 2 is 6 pi over 2, which is 3 pi. Is it safe to say that there's a pattern here yet? I think there is. And then, well, you see that 5 pi over 2 is pi over 2 more than 2 pi, and 3 pi is pi over 2 more than 5 pi over 2. So this term is always going to be pi over 2 more. So cosine, what's 3 pi plus pi over 2? Well, that would be 7 pi over 2. And 4. you see that these two always match, so the next one will be cosine 7 pi over 2 plus cosine, well, that's pi over 2 more, so 8 pi over 2 would be 4 pi. Alright, so if you don't have a calculator, you definitely have to know your trig here. The cosine of 2 pi, so you have pi over 8. Cosine of 2 pi is the same as the cosine of 0, which is 1, plus the cosine of 5 pi over 2 is the same thing as cosine of pi over 2, which is 0. And then cosine of 5 pi over 2, we've already done that, that's 0. Cosine of 3 pi is the same as the cosine of pi, which is negative 1. Cosine of 3 pi again is negative 1. Cosine of 7 pi over 2 is the same as the cosine of 3 pi over 2, which is 0. I'm sorry, I didn't mean to put a comma. And finally, the cosine of 7 pi over 2 is the same, well, we already did that, that's 0. And then the cosine of 4 pi is the same as the cosine of 2 pi, which is 1. So 1 minus 1 minus 1 plus 1, they all cancel out. So pi over 8 times 0 equals 0 units squared. Ain't that something? All that work for an answer of 0. Awesome. Alright, so look, the TRAM is always going to be aggravating because it's more work, but just remember, it's just more work. It's not something that's impossible. Alright, let's move on to number 4. I'm going to let y'all take a final look at that. Alright, moving on. Number 4. Extra practice. So we got 5 pi over x. 5 over x, not 5 pi over x. We're doing an RAM. We're going 1 to 7. And we got 6 sub intervals. Now, the first step is to find pi over x, but it's pretty common sense. If you've got from 1 to 7, you've got 6 sub intervals, each of your rectangles are going to have to be 1 unit wide, right? So here we go. Alright, so first draw your graph. We're on 1 to 7, so no need for a negative x-axis, only use positive. Alright, and then we have 1, 2, 3, 4, 5, 6. Oh no! Gotta increase my x-axis. Alright, 7. Alright, so we got this swoopy doopy thing. Alright, you plug that in your calculator, but I'm pretty sure it's just going to be a curved line. We know what it looks like. Well, let's go ahead and do some simple math right here. When I plug in 1, 5 divided by 1 is 5, so 1 comma 5 is here. And then plug in 2, 5 divided by 2 is 2.5, so 1 comma 2.5. 2 comma 2.5. And then plug in 3. 5 divided by 3 is, oh my goodness, 3 comma, it's 1 2/3, so 1.6 repeating. And then 5 divided by 4, 4 comma 1.25. 5 divided by 5, obviously 5 comma 1, and then so on and so forth. So you see how we could probably, if this is a RAM, 1 to 7, 6 subintervals, we could pretty much figure out how high those rectangles are. I'm sorry, I'm being distasteful here. And we could probably do it the easy way, but we're not about doing it the easy way. We're about learning these formulas, okay? And this is kind of like the this is not fun and intrinsic and super challenging part of calculus, but it is a lot of work and we have to get through it. It is a very important part of calculus, yes. Alright, so we start off with our delta x is equal to b minus a over n. Alright, so delta x is equal to 7 minus 1 over 6, which is just 1. Yay, we got one step down. And now we get our x of I r. The formula is a plus delta xi. And so x of I r is equal to a, which is 1, plus delta x, which is 1i. So x of I r is equal to 1 plus I. We have to substitute that in for x. So we got that. Alright. So now we need our f of x of I r. And we just whammo that in for x. 5 divided by 1 plus I. Wow, that was easy. Simple. So now we've got that. We're going to do the summation from I equals 1 to, how many things are we adding? 6. Delta x is 1. F of x of I r is 5 over 1 plus I. And this is shaping up to be a pretty easy problem. We're almost done. Alright, so summation I equals 1 to 6. I'm dropping that 1 off. I'm just going to write it as 5 over 1 plus I. And that's going to equal, well, I'll tell you what. Nah, we won't factor that 5 out. There's no point in it, not really. You end up with 5 over 2 plus 5 over 3 plus 5 over 4 plus 5 over 5 plus 5 over 6 plus 5 over 7. Is that it? Yep, that's it. So now you got a lot of common denominators here to get a hold of. So this is the tricky part. So what would go into 4, 5, 6, and 7? 2 and 3 don't matter because 2 already goes into 4, 3 already goes into 6. So 4, 5, 6, and 7. I don't know. Let's see. 5, 20, 5 is 30, and 4, 60. 4 goes into 60. 7 doesn't go into 60. So it looks like we may have to multiply 7 and 60 to get our common denominator. Well, that's just rough. Alright, so 60, 120, 180, 240, 280. Oh, 7 goes into 280. 7 does go into 280. Does 6 go into 60 go into? I'm not sure. 6, 5, and 4, 280, 24, 280s. No, it doesn't work. Yeah, it looks like it's going to be 7 times 60 equals, and sorry guys, you can plug this in your calculator. That's fine. That's just not how I roll, I guess. So 7 times 60 is 500 is 520. 7 times 60 is 520. Let's see, double check that. Yep. Nope. 420. Yeah, 420. 7 times 5 is 35. 7 times 6 is 42. 420. Okay. So So if I rewrite these all with a common denominator of 420, alright, that's 5 times 210, which is 1050 over 420 plus, alright, 3 goes into 420, 1, 3, 1, 2, 4, 140 times, so 5 times 140. Well, it might have been easier just to, it might be easier to factor the 5 out. Let's go ahead and factor the 5 out. We're going to do all that multiplication. Alright, so let's factor that 5 out. That 5 is out of there. Okay, so we've got 1 over 1/2 time with the common denominator of 420, that's 210 over 420 plus 140 over 420 plus, there's 4 over 420, that's 105 plus 105 over 420 plus 420 over 420 plus, how many times does 6 go into 420? I think 6 goes into 420 70 times. So no, it's not 400. Is it 420? No, the 5 goes into 420 how many times? No, 5 doesn't. Yeah, so that's, I'm sorry y'all. So that's 1 over 5. 5 goes into 420. I keep losing track of what I'm doing here. So that's 8, 5, 40, 2, 20, 4, 84 times that. 84 over 420 plus, how many times does 6 go into 420? 6 goes into that, 70, so 70 times, yep, 70 over 420, and then 7 goes into 420 60 times, so 60 over 420. I'm sorry, this is taking forever, but that's what you would have to do if you wanted to simplify it without using a calculator. So 210 plus 140 is 350, and 105 is 455, and 84, 455, and 84, 9, 83, 1, 539, and 70, 70 is 609, and 60 is 669. So you have 5 times 669 over 420, and that's where I'll quit. Units squared. Alright, should have just went ahead and got my calculator, but I'm stubborn. Anyway, alright, so if you would have added all those up, you'd have got the same thing as if you multiplied